Let's make sure it's okay. It says we're live. So, we are talking about empirical formulas. Yeah. Now, an empirical formula is a ratio, and it's just the ratio. So, for ionic compounds, the formula is always the empirical formula because it's always just the ratio between the ions. So sodium chloride is sodium chloride. The formula is always, always, always the empirical formula. Now, for covalent compounds, the empirical formula and the molecular formula can be different. They aren't necessarily, but they can be. So here we see water, H2O. The empirical and molecular formulas are the same, H2O. But for sugar, C6H12O6, the empirical formula is just CH2O. By the way, that's why sugars are called carbohydrates, carbon and water, so hydrated carbon. That's not, it's more complicated. No, that's why because they always have some amount of water and some amount of carbon. And then we have dinitrogen tetroxide, N2O4, those are both divisible by 2, so the empirical formula is NO2. Now, why would we do this? Well, it's because the first step in lab work doesn't give you the molecular formula right away. It only gives you the empirical formula. It only gives you that ratio. Now, empirical means determined by experience or observation. So we call it the empirical formula because this is the first bit of information we find. Now, the empirical formula does not give you enough information to find the molecular formula. So you can't identify the compound based just on the empirical formula. You need molar mass for that. So it takes 2 experiments to get the chemical formula. One to give you the empirical formula, the other gets you the molar mass. But once you have both of those pieces of information, you can find the molecular formula. Because the empirical formula is related to the molecular formula by a ratio. So here we have C6H12. That is, just a compound. The empirical formula is CH2. So there's a ratio between those two, 6. Now the empirical formula, CH2, shows up 6 times in the molecular formula. In the exact same way, the molecular mass, or the molar mass, is 84.161. The mass for just the empirical formula is 14.027. So the molar mass divided by the empirical mass gives you the exact same ratio, 6. So that's how many times the empirical formula shows up in the molecular formula. So that's how you use the empirical formula and the molar mass, the molecular mass, to find the molecular formula. Because you use the empirical formula to get this empirical mass, and then the molar mass divided by the empirical mass gets you this ratio. And then you just multiply the subscripts by that number. So you know A, you know B. You use A to find C. B divided by C gets you this number. That number multiplied by the empirical formula gets you the molecular formula. So, here we have glucose. The empirical formula, the molecular formula, we now know is C6H12O6. The empirical formula, we find that by our experiment, is CH2O. The empirical mass of that, we find it the exact same way we find the molar mass for any compound. We add the atoms together, so 12 plus 2 plus 16 gets us 30.026. Via another experiment, we find the weight of the molecular formula. We find the molar mass is 180.156. The molecular weight divided by the empirical weight gives us this ratio of 6. We multiply this number by all the coefficients. 6 times 1 gets us 6, 6 times 2 gets us 12, 6 times 1 gets us 6, and we have the molecular formula of what we now know to be glucose. Then we have formaldehyde. Formaldehyde has the molecular formula CH2O, which is the exact same thing as the empirical formula. So glucose and formaldehyde have the same empirical formula. Therefore, they have the same empirical weights. But they have very different molar masses, very different molecular weights. You see here, that experiment determines that the molecular weight of formaldehyde is 30.026. So this divided by that Molecular weight divided by the empirical weight gives us just 1, meaning that the empirical formula and the molecular formula are identical. Likewise, here's H2O. Empirical formula, H2O. Empirical weight, 18.015. Molar mass, molecular weight, 18.015. A divided by B gives us 1, so the empirical and molecular formulas are identical. But for this, the empirical formula is HO. The empirical weight is 17.007, but the molecular weight is 34.014. A divided by B gives us 2, meaning that the molecular formula appears in the empirical formula shows up twice in the molecular formula. So the actual formula is H2O2, hydrogen peroxide. So with the empirical formula and the molecular weight, you can find the molecular formula. So those two things, you can find the empirical formula and the molar mass in lab. So you can find the molecular formula. But how do you find empirical formula and molar mass? Now, empirical formula is what we're going to be working on now. Molar mass will have to wait till chapter 9 when we start talking about gases. So we're going to go ahead and do empirical formulae, and we will do that in the next video. I will see you in about 5 minutes for the next set of lectures.